Today we're going to be talking about solving equations where we have variables on both sides of the equation. So like it says here in the key concept, when you write an equation, you set two expressions equal to each other. So we have an expression on each side of our equation that's set equal to each other. When you solve an equation, you find the value of the variable that makes the two expressions equal. Sometimes both expressions contain a variable term. To solve this kind of equation, bring all the variable terms to the same side of the equation. And so our steps that we're going to take when we solve equations where we have these variables on the same side or on different sides of the equation is that we're going to get the variables on the same side, and then we solve it like any other two-step equation. So looking at this problem to the right, I have 2x plus 6 equals negative 3x plus 1. So I have variables on both sides. Now I want to get my variables moved to the same side. And so to be able to do that, I'm going to have to either undo this 2x or this negative 3x. Now in this case for this problem, we're going to undo the 2x. Now if I think about this just like if I had another number, say for instance like our 6 here, if I wanted to get rid of my 6, I undo addition by subtracting. And so I do the same thing here. Because this is a positive 2x, I have to undo it by subtracting. Now most of the time we won't write it in line with the equation, but for now, that's how we're going to write it. And so when I subtract 2x on this side, it gets rid of the 2x completely, and I'm left with 6. On the other side, negative 3x minus 2x gives me negative 5x plus 1. And then from there, I would solve it like a two-step equation. Now that's one option. I could also, though, take away the 2x, or I could take away the negative 3x from the right side and move it over to the other side, and that's another option that we have there. So if I want to get rid of my negative 3x, I undo a negative 3x by adding 3x to both sides. And what that can do is cancel out that negative 3x on the right to leave us with just 1. And on the left side, I'm taking 2x plus 3x to get 5x plus 6. Now looking at both of these equations, the second case actually gives us an equation that's a little bit nicer because we have a positive coefficient of our variable here. Both would end up giving us the same answer, but sometimes when you're solving equations, you want to think about what is going to give you the nicest answer. And so in this case, probably the second method would be a little bit easier. So let's go ahead and look at our first example. We have 6x minus 1 equals 4x plus 3. So looking at both sides of the equation, there's really nothing to simplify here. I have 6x minus 1 and then 4x plus 3, but I do see that I have variables on both sides, and so I need to get my variables on the same side. Now I think it's a little bit easier to take away 4x than to take away 6x, because that'll give me a positive variable on the left. So I'm going to draw my line, just like normal. And to get rid of this positive 4x, I'm going to take away 4x from both sides. When I do that, it cancels out the 4x on the right to leave me with just 3. On the left, 6x minus 4x gives me 2x. So 2x, and then I still have the minus 1 there. I never got rid of that. And then from there, I'm solving a two-step equation. So to undo addition, or to undo subtraction, I add. And I get 2x equals 4. Then to get this x by itself, I divide both sides by 2. And that'll give me the answer x equals 2. So I find that x equals 2. Now when I'm finished, I always want to double check my work. So to check the work, I'm going to replace, anywhere where I see x, I'm going to replace it with 2. So I have 6 times x, so 6 times 2, minus 1, equals 4x plus 3, so 4 times 2 plus 3. And in this case now, this is the first time that we're having to simplify both sides of our equation because there are things to simplify on both sides. So 6 times 2 gives me 12. So I end up with 12 minus 1. On the other side, 4 times 2 gives me 8, so I end up with 8 plus 3. And both 12 minus 1 and 8 plus 3 simplify to 11, so I get 11 equals 11, so I know that I didn't make a mistake. Now what I want you to do is go ahead and try Got It 1 in your workbook, and then put your answer in the space provided. Okay, so next, we're looking at several different examples, and we're actually skipping to part 3 here to look at 4 different examples of simplifying equations that have variables on both sides. So my first equation is 6a plus 14 equals negative 7 minus a. Now this minus a, I don't really love having that minus a on this side. And so I think the easiest thing for us to do here would be to move that minus a over to the other side by adding a. Otherwise, I'm taking away 6a and I'm going to end up with some negatives. So my first step, I'm going to add a to both sides. And when I do that, 6a plus a on the left gives me 7a, but I still have that plus 14, so I can't get rid of that just yet. And then I have negative 7 on the other side. From here, I solve it just like a two-step equation. So I take away 14 from both sides, and that's going to give me 7a equals negative 21. Then from there, all I have left to get rid of is that 7, so I divide both sides by 7, and that'll give me a equals negative 3. Now we're not going to check our work here just to save us some time. So looking at the second equation, this is even more complex than the first one because I see a bunch of stuff on the left side. Some of that can be simplified, and I see stuff on the right. So before I get my variables on the same side, what I'm actually going to do is simplify the left side by combining like terms. So if I have b plus 18, I can rewrite that as 2b plus 18 equals 4b. Now probably the easiest thing to do here, because our 2b is the smaller number, it's probably going to be easiest to get rid of that. And since it's positive 2b, I'm going to get rid of that by subtracting 2b. That'll leave me with 18 on the left side. 4b minus 2b leaves me with 2b on the right side. And now I just have a one-step equation to solve. I just need to get b by itself by dividing both sides by 2. And so I'll get 9 equals b as my answer. Okay, let's move on to the third one. So the third one, we have negative 1/2 c minus 5 equals 1/2 c. And so I think, again, it's easiest to get rid of that negative 1/2. So to undo negative 1/2 c, I add 1/2 c to both sides. Now think about this, what 1/2 c plus 1/2 c would give you. A half plus a half gives you a whole, so that would be 1c. So I can just write that as c. And then all that I have left now on the left side is negative 5. So this actually was just a one-step equation where I had to get my variables on the same side. So I get negative 5 equals c, and I'm finished. Now the very last one, we see a similar thing as to the very first problem where we had like a minus a. We have a negative d over here. Looking at both sides, nothing to simplify to start out with, so we can go ahead and get d, both the variables on the same side. So I'm going to move this negative d to the other side. Now if it's negative, I undo it by adding d. Think about what cancels itself out. Adding d to negative d gives you a 0 pair, so it cancels out completely. 2d plus d will give you 3d plus 9.7 equals, and then I still have this minus 17, so I still have a negative 17 on the right side. Now I draw my line. To get d by itself, I'm going to take away 9.7 from both sides. When I take away 9.7 from negative 17, I get 3d equals negative 17 minus 9.7, negative 26.7. To get d by itself, I divide both sides by 3, and that's going to give me d equals negative 8.9. And then I'm finished with that one. Now take a minute to do your Got It number 3 in your workbook. And we're going to move on and actually go to part 2. So part 2 is all about writing word problems where you have variables on both sides. Now when you have variables on both sides, something to keep in mind is that you're going to have two separate expressions that you set equal to each other, and both of those expressions are going to have a variable in them. So this example says, suppose the temperature in your town is 21 degrees Fahrenheit and rising 1.5 degrees Fahrenheit every hour. Your friend lives far away and the temperature in his town is 28 degrees and falling 2 degrees every hour. And how many hours will the temperatures be equal? Now what you want to look at is you're trying to figure out when the temperatures are equal. So you want to think about what an expression would be that would represent your town and then your friend's town. So in your town, you're starting out with 21 degrees and then adding 1.5 degrees every hour to that. So we can call H our number of hours. That's our variable, how we define it. H is hours. And then I can say, well, 1.25 times the number of hours is added on to 21. Now the friend's town is a little bit different. In the friend's town, it's starting at 28 degrees, but then it's falling 2 degrees every hour. So 2 times H for every hour. So I'm going to start at 28 and then take away 2H from that. So the expression for your friend's town would be 28 minus 2H. Now my goal is to figure out when both of those are going to be equal. So to figure that out, I set both of the equations equal to both the expressions equal to each other. So we get the expression that they have here, 21 plus 1.5 equals 28 minus 2H. Now just like with the other examples from there, you see if you can simplify anything on either side, you can't. So we end up adding 2H to both sides to get rid of the variable on the right side, move it to the left. And now I have this two-step equation once I get my variables on the same side. Then once I'm solving, I know I need to get rid of 21, so I take away 21 from both sides. That gives me 3.5, H equals 7. And then I need to get rid of the 3.5 by dividing both sides by 3.5, and that's going to give me the answer H equals 2. So what that tells me is after 2 hours, the temperatures in the two towns will be equal. Now when we're checking our work, again, what we do is replace anywhere we see H in our equation, we replace it with 2. So I take 21 plus 1.5 times 2, and then 28 minus 2 times 2. And then when I take 1.5 times 2, that gives me 3, plus 21 would give me 24. And the other side, 2 times 2 gives me 4, 28 minus 4 gives me 24. So I know that both sides are going to be equal. So let's look at our very last example together. So the very last example says a town's population is 14,000 and is increasing by 160 people every year. A nearby town has a population of 24,000 and it is decreasing by 200 people every year. In about how many years will the populations of the towns be equal? So we're looking for expressions that represent the population of each town, and then we're going to set them equal to each other. So let's start with the first town. So it says the first town has a population of 14,000 and it's increasing by 160 people every year. Now the second one, we're at 24,000, decreasing by 200 people every year, and the goal is to figure out how many years. So I'm going to define my variable as y, the number of years. Now town 1, it starts at 14,000, and then it increases by 160 for every year, so 160 times y. My second town starts at 24,000, and then it decreases by 200 for every year, so 200y. And we're trying to see when they're equal. So now from there, I have my equation and I'm ready to solve it. So I think it's easier to get rid of this minus 200y since it's kind of like dealing with a negative. So I'm going to add 200y to both sides. There is really nothing to simplify before we got the variables on the same side. So that's going to leave me with 14,000 plus 360y equals 24,000. Now next step, I want to get rid of this 14,000, so I take away 14,000 from both sides, and we are running out of room here. So that's going to end up giving us 360y equals 10,000, and then I divide both sides by 360. And I get y equals around 28 years. And it says in about how many years will the populations be equal. So it's fine for us to round there to about 28 years. And we are not going to show the checking your work step on this just to save you some time. I would like for you to go and complete Got It number 2 and then answer the question, or answer the question that you see on the page. Thank you.